Hello APCSA students. In this video, this goes with the lecture 3 slides. In this first video, I'm going to talk about simple expressions, modulus, division, integer division, and the arithmetic exception. So just a brief introduction to some of the math operations we'll be doing here. So we've been seeing some simple expressions like this already, and so to get started we just want to get used to saying them a little more and having more than just 1 plus 4. So we're going to add some more operations to the list. In a simple program, the simple program runs this. So this was what was on the slide. So if I run that, I can see that it's doing the math. So we will see more in the next video about precedence, but in general we follow the order of operations that we have in math class, so that makes it easier. So we have these simple expressions, and as I showed here, we can have numeric literals and just print these values out. What we want to be aware of is that we can also have variables. So in part 2 here, I have the same statements, but I'm now using some variable values to do the math. So I'm going to get the same result because the expressions are the same and the expressions get evaluated the same. It's just that the particular value is now stored. The individual operands are stored. Some of them are stored in variables. So we can use numeric literals. We can also use variables when we're working with expressions. So you're probably pretty familiar with the arithmetic operators at this point, but the multiplication is an asterisk sign. The division is a /, which is pretty common on a lot of calculators and other things. It shows up that way. One new operator, or maybe new to you, is called modulus. So it looks like a percent symbol. It is not a percent symbol. It is calculating the remainder from an integer division. So also down here we have some reminders that 3 times 4, as I just showed some of the math operations, that will do the math operation. If I actually want to put the text to the screen 3 times 4, then I would enclose it in double quotes, and then it would put 3*4 to the screen. So remembering that these values are different than if I were to change this to a string literal like that. So that would literally put that to the screen. So we're looking at math at this point. So one thing we need to be aware of when we're doing the division and the modulus is that we want to avoid dividing by 0. That will cause our program to quit. So let me see if I can. So we have one here. So right now it is running method part 2. You don't need to know about methods yet. It's running this one. So if I change this to a 0 and I run this, this is giving me an arithmetic exception. It's a divide by 0, and it causes my program to halt. I had 2 more statements after that line, but it stopped right in the middle of the program. So we want to avoid exceptions as much as possible. That's a big deal when a program crashes. We don't like that. So doing some sort of check to make sure we're not dividing by 0 ahead of time. So again, that is arithmetic exception. We're going to see some modulus now. So we'll talk about modulus, and then we'll talk about some quirky things that happen with division in our programs. So modulus is the remainder after an integer division. So here you would say 14 mod 4. The value is 2. So if you think back in math class, however you were taught to do long division, it may not have looked exactly like this, but there may be some similar format. So 4 goes into 14 3 times. I multiply 3 times 4 and I get 12. And when I subtract the 12 from the 4, I have 2. And here is where the decimal value would go for 14. And we're used to continuing and getting a decimal value. But with modulus, I'm actually interested in this too. I'm interested in, once you reach that decimal, don't bring down a 0 and keep dividing. Give me this value, this 2, this remainder value. Similarly here, 218 mod 5. I put the 5 into 218. 5 goes into 21 4 times. That gives me 20. I subtract those 2 and get 1. I bring down the 8. 5 goes into 18 3 times. 3 times 5 is 15. I subtract that 15 from the 18 and I get 3. And I've hit where the decimal value belongs, and so I stop. And this value down here is the value returned by mod. So the 3 is returned. So a couple more examples here at the bottom. So modulus, and here's some more examples as well, and I have these in the program that I could run. In fact, let me do that. So rather than running part 2, so in part 3, so here is part 3. This is straight from the slide. And so 45 mod 6. 6 goes into 45 7 times. That gets me up to 42. And then I have those 3 left over. So that's where this 3 comes from. 2 mod 2, 2 divided by 2 is 1, and there's nothing left over. So the result from mod is 0. Any number mod a number that's bigger than it, it's just going to be this value. So you'll notice the 8 is smaller than the 10. And in these first 2 examples, the first number was either larger or equal. So again, when the first number is smaller, that's going to be your result from the mod. So 8 mod 10 is just 8. And then here, when it goes to do 11 divided by 0, I get that arithmetic exception again. So I'm unable to do that. So it is still performing a divide, so to speak. So I'm going to comment that line out. These last 2 I'm not even going to talk about because they're not on the AP exam and they don't make a ton of sense, but it's just what happens when you introduce a negative value. So with mod, we are mostly talking about integers. We wouldn't really do modulus with doubles, at least not for this year. But it comes in very handy. So I'll talk about some uses towards the end, but just getting used to what mod returns. So moving on to just talking about all the operations. Now we've learned a little bit about what modulus is. So you have all these operations and they are performed on int values and double values. And depending on how we mix those 2 operands, the result will be an int or a double. So you can see that if the 2 operands are integers, the result is an integer. If the 2 operands are double, the result's double. That makes sense. If they're mixed in any way, the result is double. So if one of the operands is a double, the result is also a double. So this is the one we're going to look at, and this is the one that trips students up the most, is that when I divide 2 integers, the result is an integer. So we ignore the decimal value. So we're going to see here, 14 divided by 4. 14 is an integer, 4 is an integer. I can see it by looking at it. If they were variables, I would go check the type of the 2 variables. But 14 and 4, as they are written here, are integer values. So the result from that division is 3. It's not 3.5 and it's not 4. We don't round up. We do the division till we hit that decimal spot and then we stop. So this is the result from the division. If I asked 14 mod 4, then you would give me the 2 down here. So there's some more examples here of division where we, I just want to know how many times does 5 go into 32? It goes in 6 times and the remainder would be 2. The 6 times is the result of the division, integer division. The 2, the remainder 2, would be the result from a modulus. So 32 mod 5 would give me 2. So getting used to integer division and modulus is a big, something we really want in our toolbox to be able to refer to some of these examples. The minute I introduce a double, so here I've changed the 14 to be a 14.0, that's a double value. I can store that in a double variable. The minute I introduce a double, then we get the decimal value in the result. So then I would get the 3.5. And so there's some more examples here as well of double values when they're introduced with the division, that the result is a full decimal value. Repeating numbers will go on very long. So if I have 1.0 divided by 3, I am going to get 0.33333333. So, okay, so modulus and division can get used, the integer division and modulus get used together a lot for in a couple of instances. So I'm just going to briefly talk about these, but so here's an example where we have 137 cents, and I want to know if I'm giving someone change, and I want to maximize or minimize how many coins they get back. How many quarters, dimes, nickels, cents would I give them? So we can use a combination of integer division and mod to calculate this. So when I divide by 25 and I get 5, that's going to tell me how many quarters I give the person. When I mod by the 25, that's going to tell me what is left over. How much do I still have to account for? So I'm doing this dividing by 10 because a dime is worth 10 cents, modding by 10 to get what's left over, dividing by 5 for how many nickels. There's no nickels, I only have 2 cents left, and then modding by 5 to get what's left over. And then I don't even really need to divide by 1 penny. I just know whatever's left at this point is how many pennies I return. So we will see the division and the modulus being used together. Let me go back up to this. Also down here, these are some other applications of modulus. You can strip digits. So if I have the number, the integer value 230857, I can actually get what the value is in the ones place by modding by 10. So that's going to return the 7 to me. So I'm going to know what number's in the ones place, and that comes in handy. I can similarly use that divide mod to end up getting every one of those digits, the 2, the 3, the 0, the 8, the 5, the 7 individually. Again, that's another use where I would combine the integer division and modulus together. Another use for modulus that we'll see in much later units is for checking for divisibility. So any number, 568, if I mod it by 5, if the result is 0, that means it's divisible by 5. So I can use modulus to determine if a number is divisible by another number or not. So if a number is divisible by 2, that's going to let me know whether it's an odd or even. So I can use those. So we haven't learned if statements yet, but I just want to give you a little glance, a little look ahead on ways that we'll use modulus throughout the year. So again, any number mod 2, if it equals 0, if modulus 2 returns a 0, it means it's an even number. If modulus 2 returns a 1, which is the only other option, then it's an odd number. And then for that divisibility by 5, if mod 5 returns a 0, I know it's divisible by 5. If mod 5 returns a 1, 2, 3, 4, which are the only other options, I know it's not evenly divisible by 5. So in the next video, I will talk a little bit about precedence and tracing some of these operations on code and also assigning them to variables, and then a couple other things. So I will see you in the next video. Happy coding!